So hello everyone. So in this lecture 3 we'll try to understand the equation of a line, more precisely vector equation of a line, because we are defining the line in Vn. So when you have defined a line, what we had a point and we had a direction. So let P be the point, A be the direction, which is non-zero, of the line L of P comma A. So this set contains all points of the form P plus TA. T belongs to us, and these are all the points on the line. Okay. So basically here T is the parameter, so the variable, right? T is the only variable because P and A are fixed. So if we use this T, we can somehow define a function in the form of x of t. So x is a function from R to Vn such that x of t equals to P plus Ta. So this P plus Ta is also a point in Vn, because this is nothing but the sum of two vectors, right? So it goes from R or V1 to Vn. In particular, if you put t equals to 0, you get x0 equals to P. Similarly, x of 1 goes to P plus A, x of minus 1 goes to P minus A, x in general x of t goes to P plus Ta. Okay. So that's why this is called a vector equation. So basically you can represent a line in the form of a function, not only a function but a vector function. Okay. This is also called the vector parametric equation of the given line L of P comma A. Okay. So when we can define, as long as we have a given vector capital A non-zero and a given point capital P, we can define a vector parametric equation of the line through P along the direction capital A. So you'll see that in 2 dimension we'll exactly find this equation as the Cartesian equation of a straight line. So how to get that? So let n equals to 2 and we set 3 points. Basically one is capital P, another is capital A, and the third one capital X, basically P plus Ta, that will also be in V2 for n equals to 2. So let P, capital P is P comma Q, small p comma small q, capital A is small a comma small b, capital X is small x comma small y. Then from this equation x of t equal to P plus Ta, from this equation we'll get that x of t is nothing but P plus Ta. So we write in component form, we'll get small p plus t times small a comma small q times plus small t times small b. But this is nothing but capital X and X is nothing but x comma y. So two vectors are equal if and only if all the components are equal. That means small x is this. Now capital A is a non-zero vector. So without loss of generality, let the first component is small a is non-zero. So we can divide by small a, so we'll get the value of t. Put this value of t in the second equation, we will exactly get this equation 1. And this equation or this, these are the same equation, and this equation is called the Cartesian equation of the given line L of P comma A. Okay. So this equation should involve only the point x and y. It should not involve the parameter t. Okay. This is called the Cartesian equation of the line. Now one can rewrite this equation as in vector form. So capital X minus capital P dot capital N is 0, here capital N is B comma minus A. Okay. Now you see that the dot product of capital A and capital N is 0. That means that N is perpendicular to the vector capital A, and capital A is nothing but the vector parallel to the line. So in that sense, this vector capital N is perpendicular to the given line. Okay. So we'll see that this vector capital N is somehow very useful to find the distance of a point to a given line. So we'll discuss this in the next lecture. So we'll stop here and we'll continue the discussion in the next lecture. So thank you.